talk a little bit about lesson 2 real quick, properties of gases. I have them all listed here for you, but a couple things that we need to take note of here, things that are important for us. So I was going to make a copy, but I was just like, well, I think we'll just talk about them instead. So we're going to talk about gases this unit, of course. Okay. The first lesson was all about, here's some math that we need to know about molecules and moles and mass and molar mass and how do we do all that, of course. A little bit of review on scientific notation and all that good stuff. Now we're going to get into the actual gases part here of this unit, so this will probably be new for the most of us. The first thing we have to understand is gases will always fill their container. They have not a specific shape of their own. They will take on the shape of their container. So if we take gas, and let's say you take, for example, the room here, if we sealed it off completely, the gas in this room would take on the shape of this room. Okay, they'll spread themselves out and take on the shape of this room. If we took all the gas that's in here and put it into my coffee cup, it takes on the shape of this container now. Okay, so the volume might have been that whole thing before, like this whole space. Now it's this coffee cup, whatever fits into here. Okay, about, I don't know, 800 milliliters or so. Okay, obviously, we'll talk about what happens when that takes place, but that's what gases always take on the shape of their container. So we put it in for example, propane gas. You put that into a propane container, it takes on the shape of the propane cylinder, okay, etc. Okay. Gases are highly compressible because there's a lot of empty space between gases. So right now, I'm able to do this pretty easily. There's hydrogen in the air. There's nitrogen, which is the most abundant. There's oxygen. There's carbon dioxide. I don't remember if I said oxygen. There's probably a little bit of water gas. But gases have a lot of empty space. I'm able to move my hand between them, okay? Cut them through. So if you take those gases and you compress them, or in other words, force them together, they're easily compressible because there's a lot of empty space between them. So there's a lot of place for those molecules to get even closer together, okay? Gases become significantly smaller when pressure is increased and significantly larger when pressure is decreased. Gases diffuse spontaneously through any available space. So if we do not, for example, right now, gases are probably escaping underneath the door right now, and some are probably coming back in. If I put all the gas into this container here, or you open up a propane cylinder, okay, and we decide, oh, we're going to open it up, all the gases are going to leak out of there, right, into their environment. Same thing with a propane cylinder. If you decide to turn it on, there's a safety valve, but you push that or whatever kind of thing, you could leak out all the propane. Okay, so gases will diffuse through any spontaneous or any available space. So most of the time when we study gases, we have to make sure it's a closed system. In other words, gases cannot escape, because if they do escape, then what happens to the pressure? If I put a bunch of gas into here and I don't close the lid, well, they're just going to leak back out again, right? I can't really compress them or anything like that. They'll just leak out somewhere. Temperature has a big effect on the volume and or the pressure of a gas. So that's one of the gas laws we're going to talk about in this unit here. Temperature has a big effect. What happens when you, what does temperature do? What does temperature do for you? If I turn the heat up in this room, what happens to the gases? They, what? Huh? Heat up, yeah. And what, as a result, they gain what? We know this. What happens when you heat up the molecules? They go faster. Yes? They go faster. And the faster they go, the more collisions you could have. Yes? Okay? So that's what we're going to talk about as well. And gases mix easily with other gases because of the large empty spaces present in all gas samples. So those are the 5 properties of gases. You probably need to know those. Okay, so star those, make sure you study those, etc. Okay. Kinetic molecular theory. This is what I was just talking about here. Okay. Also, I think we should know this. We should know this by now. So hopefully I'm not telling you anything new. But particles are always moving. Okay, always. Whether they're in solid, liquid, or gas form, particles move all the time. They have kinetic energy. The more kinetic energy they have, so example, you heat them up, the more kinetic energy they have, the faster they move. Okay? This motion is random. It's called Brownian motion. Don't worry about that. But the motion's random. Okay, you can't really predict where they're going to go. Okay, good. Okay, so 3 parts of the kinetic molecular theory. Know that when you heat up gases, they start to move faster. If you cool them down, they move slower. Okay, that's why we put food in the fridge. Okay, slow down the particles, slow down the molecules. All right. There are 3 types of motion that are associated with different states here. All right. Mostly, when we talk about solids, in solid form, and you can just draw these nice and big here so you don't have to draw too many. Okay? In solid form, these molecules can't really move anywhere because they're connected together too strongly. So all they can do is they have motion. Okay? They have motion. They want to go. They want to be free, but they can't go anywhere because these forces, whatever they happen to be here, those forces hanging on between these molecules are too strong to let them go and be free. Okay? Maybe they're, I don't know, maybe it's London forces, maybe it's dipole-dipole, maybe it's hydrogen bonding, maybe it's ionic or metallic. I don't know. It depends on the molecules. Okay? But those forces are hanging on too strongly for them to go independent. So all they do is sit there and they vibrate back and forth. Vibration, okay, is what solids do. If you watch a video about molecules, they just sit there and they just kind of vibrate. They want to go. They're trying to move, but those forces are too strong. Hold them in place. Okay. In liquids, we have some spaces here. So we're going to have some spaces. Okay. So we got a little bit of spaces. Some are connected together. Not all of them are connected together. Okay. And so we talk a little bit about, in this case here, what are some types of motion we get here. Mostly probably vibrational, so they can vibrate back and forth, the ones that are connected, and some rotational, probably, I'd say. Translational, yes, in the term that they kind of slide back and forth between, right? So I guess translational as well in that regard, okay? So they're able to basically spin, turn around. They're able to move in a straight line, slide past another one. And what's the other one? Rotational, translation, vibrational. So they can vibrate back and forth if they needed to. Okay? And with gases, okay, this is where we have independent molecules, basically, kind of thing. Remember, there could be some attractive forces between these still, whatever that happens to be. However, those attractive forces are not strong enough to be solid, not strong enough to be even a liquid. They pass by each other, there might be a slight attraction, but it's not enough to hold on to each other. Mostly we talk about translational. Okay? In other words, they move in a straight line until they hit something else. Right now, there's gases in the air. Okay, it's right there, and it's going until it hits until it basically hits the wall. Okay, or hits your head or something like that. Okay, it's going to move in a straight line until it hits an object, maybe another molecule, and in which case they bounce off each other. Okay, so those are what we talk about for those things. We're going to focus on gases, obviously. So we're going to talk about translational motion. Okay, particles are spread far apart and freely move past one another. Okay, good. So just a little bit of reminder. Most important thing, of course, is kinetic energy, and then the 5 things that we talk about with properties of gases. Okay, and that should take care of that. Good. And then